Hello, geometry students. We're continuing our work with the magic of the right triangle. Today, we're going to talk about the special pattern that happens whenever you have an isosceles right triangle. Whenever you have an isosceles right triangle, or a 45, 45, 90 triangle, meaning you've got a right angle and two 45 triangles, if that happens, their side lengths have a specific pattern that they always follow every time. When you have an isosceles right triangle, the two legs will be equal, and the length of the hypotenuse is always the length of the side of the leg times root 2. Now remember, root 2 is an irrational number, so you can either leave your answers in radical form or you can round to a decimal in tenths or hundredths position. And so the leg lengths are equal in an isosceles triangle, and to find the length of the hypotenuse, you just take whatever the leg length is and multiply it by root 2. So it's the easiest possible problem you can face is if you're given the length of a leg. And one thing that can be tricky with this is if the right triangle is rotated in space, you have to pause and really decide, wait, what am I given? Remember, the right angle is across from the hypotenuse. So look where for the right angle. The two sides shooting out of the right angle are the legs of the right triangle. So you have to get your bearings if the right triangle is rotated in space. So here we see that this is a leg, and if this is a leg, we know both legs are congruent, so over here will have to be the same. And then we also know that in order to get the length of the hypotenuse, we will just take whatever that is, in this case 9, and multiply it by root 2. So we first put our pattern right on the triangle, and then we see that the hypotenuse will be 9 root 2. So pause, try on your own, and then press play for the solution. So we have to get our bearings. We see the right angle is here. So these are both legs. So we're given a leg. First thing we do is we write our pattern right on our diagram. We realize that the legs will be the same, and the hypotenuse will be whatever the leg is times root 2. In this case, the leg happens to be 2 root 2. Well, 2 root 2 times another root 2 is 4. And you're welcome to just use your calculator for that. So the hypotenuse length in this case will be 4. Pause and practice on your own paper and then press play. The first thing I would do is I would draw a picture and I would add the information you're given. In this case, you're given the length of a leg. And so I would draw that right on there. And you know that because it's a 45, 45, 90 triangle, we have an isosceles triangle, so we know the legs will be the same. And then in order to figure out how long the hypotenuse is, we take whatever the leg is and we multiply it by root 2. So we label with the pattern, and our hypotenuse will be whatever that leg is. In this case, the leg was 5 root 3 times root 2. And root 3 times root 2 is root 6, so our final answer is 5 root 6. Or if you do a decimal approximation, you'll get 12.25. Now, what if we're given the hypotenuse? Then we have to think about it a little differently. We're working backwards in that case. So again, your first step is always to get your bearings. The side across from the right angle is the hypotenuse, and the two sides shooting out of the right angle are the legs. So we know once we find one leg, we know both the legs, because in this case, it's an isosceles right triangle. But how are we going to do it? This time we're working backwards. So the first step is to write the pattern on your diagram. We know the legs would both be x, and we know the hypotenuse would be whatever the leg was times root 2. And so our equation can be 6, the hypotenuse, is going to equal x root 2, where x is the leg length. And so we can use this equation and solve for x. So we can solve for this equation for x by dividing both sides by root 2. And then when we do that, 6 divided by root 2, you can use your calculator. and you'll get a radical of 3 radical 2, or you can get a decimal approximation 4.24. And I don't care which form you put the number in, radical or decimal. It's fine either way. So pause, practice finding the missing leg lengths, and then press play for the solution. Again, the first step is to get your bearings. Across from the right angle is the hypotenuse, and I see that it's a 45, 45, 90, which means it's isosceles. So if I could find one leg, I'd know them both. So the next thing I can do is write my pattern right on my diagram. The legs will both be x, and the hypotenuse will be whatever x is times root 2, whatever the leg is times root 2. And we're given, well, the hypotenuse is 8. So here's our equation. And then we solve our equation so we can find x, the leg length. We divide both sides by root 2. And if you punch that into your calculator, you'll get 4 root 2, or a decimal approximation is 5.66. So pause, practice on your own paper, and then press play. First thing you want to do is draw a diagram for yourself and put the given information on the diagram. Then you can add the pattern right onto the diagram. You see that the leg lengths will both be x, and the hypotenuse is whatever the leg is times root 2, or x root 2. And now we have an equation that we could solve for x. To solve that for x, we divide both sides by root 2, use your calculator, and you'll either get 5 root 2 if you leave it in radical form, or you'll get 7.07 if you get a decimal approximation. So that is it for the 45, 45, 90 triangle pattern. And so I will leave you with this picture of Barnaby, my younger child's cat, when he was just a kitten. Have a great day.